So, hello everyone, this is lecture 9 for the atomic physics. In the last lecture, we were studying about the spin orbit coupling, and we get that how we get these spectral terms. Means for single orbit, you will get this splitting of two orbitals. That is because of the spin and it has quantized in the z direction. That's why we get parallel and anti-parallel spin, and we get these two spectral terms. Now, see the target which have today is that we are having two splitting. So now it will split like this. Now what will be the energy difference between this and which splitting or which p half or p3 by 2 will be upside or downside. So we need to check that, and what will be the shift of this energy, we call that perturbation in the quantum mechanics. So we need to find this gap also. So for that we will consider, means first we will calculate the magnetic field which will be produced by the orbital electron at the particular this point, and that magnetic field will just break the isotropy of this space, and now the spin magnetic moment will interact with this and give you this energy. So we need to find this energy actually. So what will be the energy in the upside and the lower side, and what will be the difference? So spin orbit coupling is responsible for the doublet splitting in one electron system. It is relatively weak interaction, but it is responsible for partly for the fine structure of excited states of the one electron system. Now see, we are not gonna go into the derivation of this formula that what will the magnetic field at this point due to this orbital current loop. So we'll just directly write, we means we derive it by the Biot-Savart law, but here we'll just directly use the formula. So due to the orbital motion of electron around the nuclei, a magnetic field is created, that is Bl equal to mu naught by 4 pi half Ze divided by mr cube L. This is your orbital angular momentum. Now we need to find the interaction energy at this point. So this will be just simply mu dot B. So mu is magnetic moment and B is the magnetic field at this point. So interaction energy of spin magnetic moment with the magnetic field created due to the orbital motion will be given by VLS is equal to minus mu s dot BL. Now see, from BL we can write from here, and mu s we already know this formula, minus GS E by 2 ms. So we will substitute it here, so minus will cancel out, will give you plus here, it will be BL. Now substitute this BL complete value here, so we get this formula for the potential or the interaction energy, that will be mu naught Z E square. You don't need to remember this, I will tell you what you need to remember, so only remember that. So yes, and this thing is very important according to the exam point of view, because the direct question asks from here. So mu naught Z E square by m square r cube 8 pi L dot s. Now see, we need to find the average value of this 1 upon r cube. So expression value of 1 upon r cube from the quantum mechanics. So this is nothing but this. So you don't need to remember this also. That is z cube by r naught cube n cube L plus half L plus 1. So we are just seeing that how we derive this. Now just substitute the 1 upon r cube average value here in place of this 1 upon r cube. You will get this mu naught e square z for 8 pi m square n cube r naught cube L plus half L plus 1 s dot L. Now this whole term is some constant A, so we'll denote it by A, and we'll write it A L dot S. So this is the perturbation term in the energy. So now you need to remember is this A, which is this thing, is proportional to the Z4, that is the atomic number. Now we need to find this L dot S. So what we'll do, we'll just do the vector addition. So we know if this is L, this is S, and this angle is theta. So J will be L plus S simply. So we know, just square this z side. Z square will be L square plus S square plus 2 dot ls. So L dot S from here, it will be half J square minus L square minus S square. Now quantum mechanically we know that this magnitude is quantized, that is Jj plus 1 h cut, means under root Jj plus 1 h cut. So square will give you Jj plus 1 and h cut square. Similarly for this, LL plus 1 h cut square, SS plus 1 h cut square. So h cut square will be taken common. Now see, this will be means L dot S is this, substitute this value here. So VLS will be A dot. Now this half will come here, means you already have this half, so it will be A by 2 and this complete term and h cut square. Now this is your perturbation term. So this perturbed energy in the form of the potential energy comes into the picture due to the LS coupling taking place magnetically. So this term only comes because of this LS coupling, otherwise it won't be there. So that's why we are getting these. Now for the J, we have two values, L plus half and N minus half. So we already know that that is L plus MS we have seen. So it was plus half and minus half. But see, S will remain same, that is half. So S can't be plus minus, it is simply half. But see, parallel and anti-parallel will give you that magnetic spin quantum number, that is plus minus half. That's why you will get two different values of J and single value of S. So we'll calculate the value of this potential. That will give us the energy of these two levels. So for first level, we'll just took J equal to L plus half. So for J equal to L plus half, if you substitute in place of J, substitute L plus half, in place of S, just write half and solve it, you will get L. And if you substitute L minus half, and s half, in place of this whole thing you will get minus L plus 1. That will be this. Now see, these substitute these values in this formula, that is a by 2 and this value and h cut square. So for this one you will get a by 2 L h cut square for j L plus half, and here it will get L minus half, this will be minus a by 2 L plus 1 h cut square. Now see, this is the negative sign, this will give you that this energy for L minus half, it will be in the downside, and it is plus sign, so it will be on the upper side, so you get the two different energies. Now means for this splitting you have these energies. Now also you can find the difference also. Difference will give you simply sum of this minus this will give you plus of this. So just take the sum, that will give you a L plus half h cut square. So this is the energy difference between the splitting of the doublets. So this formula you must remember, and these two formulas you must remember this. Direct question can be asked from here. Now see, when there was no spin orbit coupling, then H, that is your Hamiltonian, will give the total energy. So this is the energy operator, which is simply kinetic energy operator p square by 2m plus potential energy. And if you take the operate this on the psi, that is wave function, this will give you energy eigenvalues, that is E n psi n, where E n is nothing but minus RHS RSC divided by n square z square. So you are having just simply these terms. But see, when this spin orbit coupling comes into the picture, there will be some perturbation term in the Hamiltonian. So what will be that? That will be this A L dot S, which we just discovered here. So now your H total Hamiltonian is nothing but, so total Hamiltonian will be simply this H naught plus the perturbation term, that is A L dot S. Now see, if you operate this on the wave function, then you will get two values for L dot S. That's why there will be two values of eigenvalues. Now it will be S dot, and that is give you En, plus for this you will get two values, a by 2 L h square and a by 2 L plus 1 h square. So these two values will be there. So that's how you can also see this quantum mechanically. Now we have these values, so just let's see some numericals based on this. Spin orbit interaction in atom is given by this. So it is given, we need to find the splitting between this f7 by 2 and f5 by 2. So see, we need to write it in terms of A. So we know splitting energy is given by AL plus half h cut square. So for F we know SPDF, that is 0 1 2 3. So just to substitute 3 here, it will give you A7 by 2 h cut square. This will be your answer. For D it will be 2. For n place of L, just write 2 and you will get answer 5 by 2 h cut square A. For P it will be 1, so it will be 3 by 2 h cut square A. So that's how you can solve simple question asked from this chapter. So now next question is perturbation is given, that is V perturb, that is AL square, is added to the hydrogen atom potential, the shift in the energy level of the 2p state. So we need to find the shift when the effect of the spin are neglected upon the second order in A. So we need to find the split. So see, h cut psi is given by E n psi. But this is the normal, but when there is perturb term involved, so h psi will given as h dot s naught plus a l square. This is your perturb term psi. Now just operate them separately. So al square psi. Now l square we know quantum mechanically this will given by simply l plus 1 h cut, and square will give you l plus 1 h cut square. So it will be this al l plus 1 h cut square psi. Now see, this is your normal term and this is your perturb term. So this is the shift in the energy which you will get. So they asked us for the 2p. So for p, L equal to 1. Substitute L equal to 1 here, you will get 2a h cut square. So this will be your split in the energy. Next is the magnitude of the magnetic dipole moment corresponding to the spin of the electron is. So we need to find the magnetic moment, that is mu is equal to minus GSE by 2ms. We know this formula. So this is S is nothing but under root S plus 1 h cut. So this will be Bohr magneton. And just substitute in place of S half, you will get this under root 3 mu b. That will be your answer. Now last question for today, that is a beam of electron enter in the uniform B along z axis, and energy difference between the electrons having a spin parallel and the anti-parallel with B is. So we need to find the energy difference between the two splittings. So U is given by minus mu s dot B. We know this. So we will find the mu s z component because of the parallel and anti-parallel. So there will be just differences only in the z direction, the parallel and the anti-parallel. So it will be minus, and this will give you minus mu s z will be minus gs e by 2 m s z b. So s z is nothing but ms h cut. And now see, for gs, you know, for the spin it will be 2, so 2 will cancel out, and ms will be plus minus half, so you will get plus minus eh cut by b by 2m. This is your energy. Now difference is simply plus 1 minus this minus 1, so it will give you difference. It will be simply eh cut b by 2m minus means plus eh cut by 2m, it will give you eh cut b by m. This is your energy split difference. Now you have the answer which they asked. Now they can also ask that how much energy is required to flip the spin. Means the plus one have minus and minus have plus. So this much amount of energy will be required. Same energy is required to flip the spin also. So they can ask you. So this will be the same energy. So that's all for today. In the next lecture, we'll discuss some more question. Then we will move forward. Thank you, everyone.